Good morning, my dear friends. See now, today we shall start with another chapter. Okay, I think this is in the third unit. Okay, a third module. Okay, it is now how to calculate the ultimate strength of PSC beams in flexure. In a sense, when a beam undergoes bending action. Okay, so at that time, how to calculate the ultimate load carrying capacity of that beam. Okay, see now, if you just recall in our first chapter, where in the stress analysis, okay, you have solved so many problems. Okay, so there we have seen some of the problems we have seen that how to calculate the live load a beam can carry. Say he used to give you that he has applied so much of pre-stress and cross-sectional area of the beam, etc., he has given. Okay, you have calculated how much load or how much live load your beam can carry, or how much is the moment of resistance of that beam. Okay, you have studied in some of the problems. Same thing now I want to calculate the load carrying capacity in its ultimate state, when the beam undergoes the ultimate state. Oh, sir, now at that time I want to calculate how much load it will take. See now, the exact analysis for the ultimate strength is very very difficult, because you know that uh, in ultimate strength, okay sir, or whenever it reaches the ultimate state, okay, so now both your concrete as well as steel, they will be stressed beyond their elastic ranges. Is it or not now? So it's very difficult to find out the ultimate strength, but still, okay, there are some efforts which have been done. Okay, and different codes will give you different criterias how to calculate the ultimate strength. So accordingly, Indian standard code provisions are there. As I said, we use IS 1343 1980. Similarly, British standard code also has given some of the rules and regulations. Similarly, American code also has given some rules and regulations to calculate the ultimate strength. So now we'll try to see now how exactly the what exactly the Indian Standard Code says. In sense, IS 1343 1980. Okay. So now please try to now understand now this. Please try to understand this figure very very carefully. Okay, sir. Now, see now here I have shown one beam of dimension. It's a rectangular beam. It's a rectangular beam of dimension B, and overall depth is D. Its effective depth is small d. Okay, and here I have got a neutral axis NA. Okay, which lies at a distance of XU from the extreme compression fiber. Okay, and here he has kept some area of steel. He calls it as AP. AP means it is the area of pre-stressing steel. Okay, AP indicates that it is the area of pre-stressing steel. Okay, see now, for this rectangular section, now we shall try to find out how to find out the ultimate moment of resistance. See now, for this Indian Standard Code uses, oh sir, now this thing now, what now? A rectangular parabolic stress block. Okay, so whenever it reaches the ultimate state, oh sir, now at that time the stress block in concrete becomes rectangular parabolic. I think the same concept we have used in our RCC also, whenever you were studying the limit state method of RCC design. Okay, so now here what it assumes is now this extreme compression fiber will undergo a stress of 0.45 FCK. 0.45 FCK. FCK means it is the characteristic compressive strength. Oh, sir, now, and now this stress block is rectangular up to here, then a parabolic from here to here. So I will call it as rectangular parabolic stress distribution, or it is called rectangular parabolic stress block. Okay, so now see now, at the center of this steel, pre-stressing steel, there occurs a ultimate tensile force TU, because these cables are under tension. So now tensile force is marked in this direction, and we call it as TU. TU Baba now, TU is given by FPU into AP. In the sense it is stress into area. Stress into area will give me the force. Okay. Stress FPU means it is the pre-stressing force whichever is there in the cable at the ultimate state. Okay. It's called FPU. AP means it is the area of this cable or area of this pre-stressing steel. Okay. See now, so now I have marked here TU. It is the ultimate tensile force which is acting at the center of this steel. Okay. Similarly, now I will mark here CU force, in the sense ultimate compressive force, which is acting at the centroid of this rectangular parabolic stress block. Baba, first find out where exactly the CG lies of this area. Okay. So at that CG point, your CU force is now acting. Okay. So now again IS code tells you that the CG of this rectangular parabolic stress block lies at a distance of 0.42 XU. At 0.42 XU, the CG lies. So now at a distance of 0.42 XU from the top, Baba, CU force is now acting. Okay, you can see here now. Okay, CU force acts at the CG, and this CG lies at a distance of 0.42 XU, where XU is the depth of the neutral axis. So now, but just like how we have found this TU, okay, it is stress into area. Okay, we have found. Similarly, we'll try to find out CU also now. CU, okay, is again stress into area. Baba, stress means it's the average stress I have to take. Baba, just if you just recall your RCC, average stress can be taken as 0.36 FCK. See now, here the stress is 0.45 FCK. It is in the extreme fiber. Okay, from here to here it is 0.45 FCK. Then afterwards it goes on decreasing as parabola. So if I want to take the average stress, so the average stress is 0.36 FCK, just like your RCC. Okay, and this average stress of 0.36 FCK is acting over this area now. Over this stress is now acting on an area of B into XU. In the sense, this on this compressive area B into XU, this rectangular area, it is now acting. So area is BXU. Okay. So now this average stress into area will give me the CU force. So CU force I can write it as 0.36 FCK into BXU. So now CU force is now acting here. TU force is now acting here. Okay. The lever arm in between them, I will call it as A. Baba, lever arm A can be now easily calculated. Entire distance is now D. Effective depth D. D minus this 0.42 XU will give me this lever arm A. Lever arm A is D minus 0.42 XU. Am I right, sir? Now, so now this is how this stress block calculations are done. So now, Baba, according to your this thing, now TU force and CU force should be equal and opposite, as you know. So TU should be equal to CU, but they are opposite in nature. Okay. So now I can write mu is equal to, in the sense, ultimate moment of resistance is equal to TU into A. Okay. As I have written, TU into A will give me the ultimate moment of resistance. Okay. It is a force into lever arm. Force into lever arm. Force, and this A is the lever arm. Okay. So TU Bobano, I know TU can be written as FPU into AP. FPU into AP can be replaced by TU. A is the it is the lever arm. Lever arm can be written as D minus 0.42 XU. D minus 0.42 XU. So now this equation will give you something, how to calculate the moment of resistance or ultimate moment of resistance. It is now. Okay. Mu is equal to FPU AP into D minus 0.42 XU. Okay. This equation will give you how to calculate the ultimate moment of resistance. So now you need not remember this equation. This equation is there on page number 59. Okay, of this IS code. That also I will show you. The equation is there here now. Okay, m is equal to fpu ap into d minus 0.42 xu. Okay, this equation is there on page number 59 of this is code. Also now, so you need not remember anything now. Now the problem is, now in this equation, AP I can easily calculate, area of processing steel. D also, effective depth also I can easily calculate. XU also I can, in sense now here, now the problem is now how to calculate this XU and FPU. Okay, if I know these two things, I can now easily calculate this MU. Okay, so now how to calculate this FPU and XU? Baba, it is given in table. In sense now, for this I have to use table number 11, of page number 59. Here he has defined one thing called effective reinforcement ratio, APFP divided by BDFCK. What these are, we'll try to see it afterwards. So now, by using this table number 11, see now, table number 11 is now here, table number 11 is here, it's on page number 59 again. By using this table, I can calculate the value of this FPU and XU. Okay, so now how to calculate it, we'll try to see afterwards. Also now, how to see that, we'll see it afterwards. Okay, thank you very much.